Alright, so today we're going to look at the regulation of glycolysis and the TCA cycle. So there are three enzymes in glycolysis that are regulated. So there can be inhibitors and stimulators of those enzymes. So first of all, we're going to look at the first enzyme, which is hexokinase. So hexokinase only has an inhibitor, and it's inhibited by glucose 6-phosphate. So why is it inhibited by glucose 6-phosphate? Isn't glucose 6-phosphate the next step of glycolysis? So we have glucose, which goes into glucose 6-phosphate using this enzyme. So why is this an inhibitor? Well, it's because if we have high levels of glucose 6-phosphate, then they can be inhibiting hexokinase to release more glucose 6-phosphate and release more energy, essentially. Now, the second enzyme that I want to talk about is phosphofructokinase 1. Now, this is inhibited and it's also activated. So let's talk about things that activate it first. So citrate is your first one that activates it. We also have ADP that activates it, and phosphophenyl pyruvate, which is the second last step of glycolysis. So all of these things activate or stimulate phosphofructokinase 1 to keep doing its job. But we also have inhibitors. So inhibitors include ATP, and that's because if we're making up too much energy, then phosphofructokinase is not going to continue. Now, ATP is our first inhibitor. It's also inhibited by AMP. And AMP is also one of those energy releasing sorts of things. So we don't want more energy because we don't want to continue on with glycolysis using phosphofructokinase 1. So that's an inhibitor as well. Now, the last inhibitor that I want to talk about is phosphofructose 2,6-bisphosphate. So this also inhibits it because it can go into other steps and lead to more energy being produced. Now, the third enzyme that I want to talk about is pyruvate kinase. Now, this is the last enzyme of glycolysis, and it has some inhibiting and activating steps. So things that stimulate pyruvate kinase include things like ADP, and also insulin can activate it as well. Insulin. And there is also phosphofructokinase 1, which goes into glycolysis, obviously, and we get a substrate called phosphate. So glucose 1,6-bisphosphate. So that is also a stimulator, because if we have more of that, that means we want more pyruvate kinase to be created. So phosphofructo 1,6-bisphosphate. And then we have inhibitors. So inhibitors include ATP, because if we already have so much energy, we don't want more, and glucagon. This is also an inhibitor. So those were all the regulatory enzymes in glycolysis. Now let's move on to the TCA cycle. So this regulation is really important to make sure that we're not making too much or too less energy. We're just making enough which is required. So there are two types of regulation, allosteric and non-allosteric. So we're going to look at allosteric first, and the first enzyme that's more important and it's regulated is citrate synthase. Now, citrate synthase is activated or stimulated by ADP, but it is inhibited by ATP and NADH. So that's our first one. The second enzyme that I want to talk about is isocitrate dehydrogenase. So isocitrate dehydrogenase essentially gets activated by ADP and calcium, but it gets inhibited by ATP and NADH. And the last one that I want to talk about is alpha ketoglutarate. So alpha ketoglutarate dehydrogenase. And this is stimulated by ADP, but it's inhibited by NADH and succinyl-CoA. So these are all your allosteric inhibitors. Let's have a look at the non-allosteric. So we have 3 of those as well. The first one is aconitase. And aconitase gets inhibited. So non-allosteric just means that it only gets inhibited. It doesn't get stimulated like these ones here. So it only gets inhibited. Aconitase is inhibited by a thing called fluoroacetate. So fluoroacetate inhibits aconitase to continue on its action. And the second one that I want to talk about is alpha ketoglutarate. Now you might be thinking, if alpha ketoglutarate dehydrogenase was here, why is it here as well? Well, it's because it has non-allosteric inhibiting sites as well. So even though it does have this stimulatory thing here, non-allosteric doesn't always mean that. Non-allosteric and allosteric can have different meanings. So allosteric means that it's got different sites in that enzyme, so different binding sites, not just one active site. It's got different binding sites, so that could be like here. If this is the active site, we could have, here, it could bind here, it could bind. So it's got all these binding sites, which could lead to different effects. So that's allosteric. Here we just have that one active site. So that's the main thing you should get out of that. So alpha ketoglutarate dehydrogenase is then inhibited by an enzyme called arsenate. So arsenite. And the last one that I want to talk about is an enzyme called succinate dehydrogenase. Okay, so succinate dehydrogenase is inhibited by malonate. And these are all the inhibitors of glycolysis and the TCA cycle. Remembering that the TCA cycle has allosteric and non-allosteric inhibitors.